So in this video, I want to focus on how logarithms help us solve equations. The idea of what a logarithm is, I did that in another video showing the tables and the graphs and everything. Here I just want to focus on why we use them and how we use them to solve equations. Before I do that, I want to solve some easier equations. Let's solve some very simple equations, like x plus 3 equals 6, x times 3 equals 6, and we can solve x to the third equals 6. Each of these equations is x and an operation and an answer. So for the first one, the operation is plus. The opposite of plus is minus. So I do the opposite to both sides. If there's math happening on one side, to unmath it, I do it to both sides. And that gives me a nice answer of just x equals 3. But I can just write 6 minus 3, and it's also correct. The second one, x times 3, opposite of times is divide. So I can write x equals 6 divided by 3. The third equation, x to the third power, opposite of third power is third root, or 1/3 power. And I could just write x equals the cube root of 6. Each of those things that I wrote in purple is something I can type into my calculator. I can type in 6 minus 3. I can type in 6 divided by 3. I can even type in the cube root of 6. We'll get these answers. The calculator tells you, here are your answers. Now, when we have a logarithm, it's the same idea. You start with an equation like 3 raised to the x equals 6. And you do an operation to both sides of that equation, log base 3 to both sides of the equation. When we did minus 3 on our first equation, that canceled plus 3. When we did divide by 3 on our second equation, that canceled times 3. And when we did cube root, that canceled cubed. It's the same thing here. Log base 3 cancels a base of 3. So we're left over with an answer, just like on our previous ones, of x equals log base 3 of 6. Just like before, your calculator has that in its menu. So if you, on these calculators, if you look right here where it says math, press that button, and you scroll down, there we go, until you see where it says option A. Should say log base. Okay, so now I'm on log base. If you hit enter for log base, you can see that it gives you a spot to type the base and to type the input. So you put a 3 in the base and a 6 in the input. You hit enter and it tells me the answer. It's not the same as the cube root. This is telling me that 3 raised to the 1.6 is equal to 6. And that's different than the cube root. The cube root is telling me that 1.8 times itself 3 times is 6. So here, I want to really reiterate what I just said because I know that was a bit confusing. Okay. This answer, 1.82, means 1.82 cubed. In other words, 1.82 times itself 3 times is equal to 6. And that's a different question than 3 raised to the 1.63. 3 raised to the 1.63 means we're multiplying 3 by itself that many times. It's a little confusing to say I'm multiplying 3 by itself 1.63 times. So if you remember that we talked a lot about how in between powers, like fraction or decimal powers, you can think of them as roots going on. So we have like whatever 1.63 is, we can represent that as a fraction. We can think about roots and we can fill in all the decimals in between. But these are different ideas. So I wanted to clarify that. So I'm just going to do one more example here with, let's do a word problem. Let's make up a word problem with everybody's favorite thing of half-life. So let's say we've got carbon 14, and we start out with 72 milligrams of carbon 14. And everyone remembers that the half-life is equal to 5730. And maybe the question is, When will we have 1 milligram? So this is a wonderful problem to solve with a logarithm. Up until this point, you didn't know how to solve this. So what I'll do is I'll set up an equation. The amount of carbon 14, so the amount of milligrams I have after a certain number of years, is I started out with 72, and it has a half-life, so I multiply by a half. I don't multiply by a half every year. This would mean every year you multiply by a half. It takes me 5,730 years, so I divide the exponent by 5730, and now I've got this. So far I've just written down my model. This is a model. If I typed it into my calculator, I could look at the table and it would tell me all at every year how much I've got. Every given year I got how much. But I have to scroll way the heck down to get down to 1 milligram. So that's why it's useful to learn these logarithms to help you solve. So I really am caring about 1 milligram. So I plug in 1 milligram for my function. Then I divide by 72 because I'm trying to get the exponent part by itself. So I'm just going to write 1/72 equals 1/2 to the y over 5730. Now on the other one, I had 3 to the x equals 6, and I did log base 3. Here I'm doing log base 1/2. Whatever the base of the exponent is, needs to match the base of the logarithm. Log base 3 of 3 canceled out, so log base a half of a half cancels out. I'm going to grab my calculator, I'm going to hit the math button, go down to option log base. I'll type in log base a half of 1 over 72. Apparently that is the answer. Okay, so it's about 6.17. So I'll slide on over here. 6.17 is y over 5730. That means it takes about 6.17 half-lives to get the answer. Last step is just multiplying by 5730, and you got 35353.67 is y. Imagine guessing checking. You're not going to get there. Imagine scrolling down on your table. You're not going to get there. A logarithm lets you cancel the base of an exponential problem. So if you have an unknown exponent, a logarithm will help you solve that equation. So thanks for watching. Again, comment if there's anything that's confusing or if there's anything else I should go over.